We are asked, given the function f of x equals x cubed minus 4x, what is the average rate of change of f over the interval -2 to 3? So we are asking for the average rate of change of the function, which is going to be how much does f change over the interval that x changes, right? Now, this is the same thing as asking how much does y change? What is the change in y over the change in x? All right? This triangle means change in, all right? So when you see that little triangle, that change in y, it's like saying y2 minus y1 over x2 minus x1. You may recognize this formula as the slope of a line, all right? So we are basically asking, what is the slope if you were to draw a line between these 2 points on this graph? So let's look at this. We know already with our change in y and change in x, we know that our x's are 3 and -2. So I'm going to take 3 and subtract -2 from it. All right. Now, our change in y, well, we need our y values for that. So let's do a little table over here. We have x, and our y's come from f of x. So whatever x is, that'll give us our y. So when x is -2, we're going to be plugging it into the function. We have -2 cubed minus 4 times -2. That is 8 minus 8, which is equal to 0. So y is going to be equal to 0 when x is equal to -2. Now, when x is equal to 3, we have 3 cubed minus 4 times 3, which is going to equal 15. All right, so this means we have 15 minus 0. So our change in y is 15, and our change in x is 5, meaning that our average rate of change is 3. All right. Now, let's take a look at what this means when in reference to the graph. So if we had the graph, let me draw some x and y axes right here. All right, here we go. So what this means, this function right here, f of x, goes something like this. All right. Oh, that wasn't looking very good. Something similar to this. Not exactly like this, but here we are. All right. It goes something like this. This is probably a little bit more like that. All right. So our function looks something like that. All right. Now, we've already found these points. This means this we're going to call -2, 0 from this point up here. X is -2 and y is 0. Now, x is 3, I mean. X is 3 is about right here, and it's going to be somewhere up here. This is definitely not drawn to scale, but that is all right. So what we see here is that the change in y from this point right here to this point over here, the change in y is 15. All right. Now, from this point to this point, from the first point to the second point, the change in x is 5. All right. So what we're doing is we are finding the slope of this line right here. Okay. This line has a rise of 15 and a run of 5. Rise over run gives me slope. So I have 15 over 5 gives me 3. Right, and that's my average rate of change of the function over the interval -2 to 3. Right? Let's go ahead and look at another example. So what is the average rate of change of y of x over the interval -5 is less than x and, yes, x is greater than -5 and x is less than -2 is what I meant to say. What I was saying was correct, though. All right. So looking at this, we can see that when x is -5, I am sitting right here on my table, right? We don't know the actual function, all right? But we can determine the average rate of change from the information we have from the table, because we also know that x is -2 is right here, so we have both the values we need to be able to do that. Now remember from up above, our average rate of change of y of x can be found by taking the two y's and subtracting them from each other, and the two x's and subtracting them from each other. Now, traditionally, we do take the second one and subtract the first one from it, but if you do it the other way around, it will still work. You just need to do it in the same order. So these two should come from the same ordered pair, and these two should come from the same ordered pair. All right. So this means that we have, we're going to start with our second one. We have 0 minus 6, and that is over -2 minus -5. All right. Now, that means we have -6 in the numerator, and we have 3 in the denominator, giving us -2 as our average rate of change. So this means that this function, whatever this function looks like, if we were to plot these points, then we would end up with some function, who knows what it looks like, that has 2 points that connect, and the slope of that line is -2. All right. Let's see, I think I have another example here. Yes, I do. So find the average rate of change of the function from the graph over the interval 0 to 1. So here we don't have the function, but we do have the graph. So this interval 0 to 1, remember this is always the x values. So the interval we're looking at here is from 0, which it is included because of the closed bracket, to 1. Now with average rate of change, it doesn't always matter that it's included or not. It's going to have the same average rate of change, but it's always good to remember that. Now let's look at the points that we have at these points on the graph. So at 0, we are right here. And at 1, we are right here. So at 0, we are at 0, 1. And at x equals 1, we are at 1, 3. So our average rate of change is going to be 3 minus 1 over 1, yes, 1, I'm sorry, minus 0. There we are. Let's check and make sure we did that correctly. So the y's, sorry, wrong one. Y's are being subtracted, and x's are being subtracted. Yep, there we are. Okay, so that means we have 3 minus 1 is 2, over 1 minus 0 is 1. So we have an average rate of change of 2. Now, if you were to draw the line that connects these 2 points, it should have a slope of 2. And you can see we have a rise of 2 and a run of 1. So we did our average rate of change correctly. We have an average rate of change of 2.